My name is Connor Black, and this is Lab 4, Oscillation of a Spring Mass System. The purpose of this lab is to model the observed and predicted motion of a spring mass system similar to those found in extreme sports with ropes, and also to observe the energy principle and how it relates to this situation. My models were relatively accurate in predicting the motion of the spring mass system from the video, and as you can see, the plot of change in kinetic energy, change in spring potential energy, change in gravitational potential energy, and change in overall energy successfully describes these values. We know this because the yellow line is equal to 0, and this is the value we should get. I'll explain this more in depth later in the video. First, I imported the video into Tracker. The origin of the axes was set to the top of the spring where it was connected to a sturdy object. The y-axis runs vertically and the x-axis horizontally. Next, I marked the points at the center of mass attached to the bottom of the spring as it moved from frame to frame. Those points can be seen in this table. Using data from Tracker, I was able to use these equations to find values for the period t, the spring constant k, and the relaxed length of the spring L sub 0. Other relevant principles and equations for this lab include Newton's second law, the energy principle, and Hooke's law. Here are some of the initial conditions of the code I used to create the model. The mass of the object was given. The initial position of the object was found using Tracker. The object's initial velocity is a 0 vector because it started from a rest, and we're starting at time t equals 0. Down below is where I imported the observed position data gathered in Tracker so that I can make a comparison between it and the predicted positions. Also, delta t was set. G, the acceleration due to gravity, is 9.81. I set the values for Ks and Lo, which represent the spring constant and relaxed spring length, equal to the values I previously calculated for them. And down here, kinetic energy K, gravitational potential energy Ug, and spring potential energy Us are defined as functions of the spring constant and the object's mass, position, and velocity. This is the loop I used to carry out the calculations. Newton's second law allowed me to identify and define the following variables. The force of gravity is defined here and is represented by the black arrow in the model. The spring force is defined here and is represented by the blue arrow in the model. The net force, Fnet, is just the spring force plus the gravitational force and is represented by the red arrow. This portion of the code is used to update the position of the spring. Here you can see the kinetic energy is being recalculated, and the change in kinetic energy, or delta K, is being calculated here. This is also done below for gravitational potential energy and spring potential energy. At the bottom is the line I used to create the plot of the energies. Here's my plot of all calculated energies. The blue line represents the change in kinetic energy. The red line represents the change in spring potential energy. The green line is the change in gravitational potential energy, and the yellow line is the total energy of the system. My plot shows that this is equal to 0, and this is true because no energy is being lost or gained from the surroundings. Therefore, the energy principle is being satisfied. Finally, with this piece of code, I made two plots, one comparing predicted versus observed x position, and the other comparing predicted versus observed y position. The red lines represent the observed position data, and blue is the predicted. Here on top, my y position data was accurate in predicting the vertical motion caused by the spring. Below, my x position data was again accurate in predicting the side-to-side motion of the spring. After multiple attempts, I found that the small amount of error you see is caused by failure to perfectly label the center of mass as it moves in Tracker. If any other point is used other than the center of mass, the program acts as if the spring is stretched differently than it actually is, causing discrepancies in the data. Thanks for watching.